Hi students, good evening. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Some Dumb for Peace. In this video session, we shall discuss your section 7.3 homework assignment. Section 7.3 deals with estimating a population mean. Please, before you continue with this video, it is highly recommended that you have read the notes and viewed the videos on inferential statistics and also on estimating population mean. It is very important. Then you can now continue with the video. As usual, we are going to use technologies to solve the questions here. The two technologies we shall be using are my calculator and Pearson Statcrunch. So let's get started. Question 1. Answer both questions A and B relating to the dot plot given below. What does it mean to say that the confidence interval methods of this section are robust against departures from normality? This means that the confidence interval methods of this section are robust against departures from normality, meaning that they work well with distributions that aren't normal, provided that departures from normality are not too extreme. Okay, they work well with distributions that aren't normal, provided that departures from normality are not too extreme. So B is the correct option. Does the given dot plot appear to satisfy these requirements? Yes, because the dot plot resembles a normal distribution. You look at it, it looks normal. Looks like a bell-shaped curve. And the sample size is greater than 30. Question 2. Do one of the following as appropriate. A. Find the critical Z value. B. Critical T value. C. State that neither the normal nor the T distribution applies. So let's say this here. For both the critical Z and critical T, the population has to be normally distributed, or the sample size should be greater than 30. Either of these conditions. I repeat, the population should be normally distributed, or the sample size should be greater than 30. Then you can calculate the critical Z or the critical T. Now, when do you calculate which one? If you are given the population standard deviation, which is your sigma, then you use critical Z. If you're given the sample standard deviation, that is just the S as in Samuel, lowercase s, then you use critical T. Okay? If you're given the population standard deviation, you use critical Z. If you're given the sample standard deviation, then you use a critical T. However, before you use either of them, you have to make sure that the population is normally distributed or the sample size is greater than 30. So if we look at this, confidence level 90%, the sample size is 23, the population standard deviation is known, population appears to be very skewed. So this does not meet the requirement. So the correct option will be E. Neither normal nor t. The normal we mean is the z. Okay, the z distribution is the normal distribution. Neither normal nor t distribution applies. Question 3. We have a 99% confidence level. Sample size is 100. The population standard deviation is unknown, but the population appears to be skewed. So even though the population is not normal, okay, it's skewed. However, the sample size is greater than 100, so that's fine. We don't know the population standard deviation, so we're going to use critical T. Question 3, let's for all the critical values, my calculator is the best to solve it, honestly, for all the critical values. So later on, as we solve some other questions in this section, we're going to use Statcrunch. However, for the critical values, let's just use my calculator, okay? So I'm going to pull up my calculator here. I'm going to go to Firefox and just go to google.com and just type in my name, Samuel Chukwuemeka. I am glad to announce that my two websites are now mobile friendly. So samuelchukwuemeka.com and then chukwuemeka-samuel.appspot.com. So the two websites are now mobile friendly. So I'm going to click here, and you can just go to portfolio, and in this video we are going to use Inferential Statistics Calculator. We're going to use this calculator, or you can click mathematics, go to statistics, and on the resources you look for Inferential Statistics Calculator. So this is the calculator we are going to use, and we're going to do critical values. So let me make sure this is the same window. Okay, I'm going to put this side by side. So we're going to use critical T here because the population standard deviation is unknown. Sigma is unknown. So they gave us the confidence level. So you find when we are given the confidence level, we are not given the degrees of freedom. So you scroll down till you find this. Let me maximize this for a moment. So this is what I'm saying here. This is the critical value. If you click critical values, you go to, they gave us confidence level and the sample size. Okay, so this is the one we're going to use here. And we have to find the critical T. So confidence level, we put 99. You select percent. Sample size, you put 100. And for this video section, we are gonna do one-tailed. It's all one-tailed. Okay, click calculate. So they're looking for the right-tailed. That's what we are looking for, the right-tailed critical T value, and that is 2.626. 2.626. So you see. Question 4. The confidence level is 99%. Sample size is 28. It is not up to 30. The population standard deviation is unknown. However, the population is normally distributed. So in this case, we are still going to use critical T because we don't know the population standard deviation. So we will use critical T. If we know the population standard deviation, then we use critical Z. Okay, but because we do not know it, and the population is normally distributed, we're going to use critical T. So we can reset this. We use the same thing, 99%. Sample size here is 28. Test is 1/3. Calculate. So the critical T is 2.7. Right-tailed is what we are interested in. Right-tailed. So it is 2.771. Critical T 2.771. Okay. Question 5. 99% confidence level. Sample size is 24. The population standard deviation was given, and it is 28.8. The population appears to be normally distributed. So that is fine. This requirement has been satisfied. Because they gave us the population standard deviation, we are going to use critical Z. Critical Z. Okay, that's what we're going to use. So you just scroll up, critical Z, Z alpha over 2. But they gave us the confidence level. Okay, so we use this one. The confidence level is 99%. Select percent and press calculate. So the critical Z is 2.576. 2.576. That's the critical Z. Here is 2.575. We select this critical Z. Question 6. Use technology and the given confidence level and sample data to find a confidence interval for the population mean. Assume that the population does not exhibit a normal distribution. So the population is not normally distributed. However, the sample size is 61. The sample size is greater than 30. So we can still go ahead and construct a confidence interval for the population mean. So let me do this with my calculator, and then the next one we do with Statcrunch. Okay, so we do with my calculator, we do with Statcrunch, we do with my calculator, we do with Statcrunch. Okay, so we need to find a confidence interval. So this is what you're gonna do. When you go to my calculator, you click on estimating population mean. Click on it. Excuse me. And you look at what we were given and then what we are asked to find. We were given the confidence level, the sample size, the sample mean, and the sample standard deviation. We were given the confidence level, the sample size, the sample mean, and the sample standard deviation. If you look at symbols and meanings, you see all these, how I explained it here, all these. Okay, so it's important you read the notes, read the definitions, look at the formulas, very important. So estimating population mean, we look at what we were given this, and we need to construct a confidence interval. So this is what we are gonna use. So let's make this to be on the same window. Estimating population mean, confidence level, and I wrote the requirements here. When requirements are met, I wrote it here. Confidence level is 90%. Put 90, select percent. The test is 1/3. Sample standard deviation is 5.1. Sample mean is 3.0. Sample size is 61. Calculate. So the confidence interval to 1 decimal place, the lower confidence limit is 1.9. The upper confidence limit is 4.1 kilogram. Okay, It says, is the confidence interval affected by the fact that the data appear to be from a population that is not normally distributed? It is not, because the sample size is large enough. Okay, the sample size is large enough. It is greater than 30. So you say no, because the sample size is large enough. Question 7, we can do this with Statcrunch. Listed below are the amounts of mercury in parts per million, or ppm, found in tuna sushi sampled at different stores. The sample mean is 1.131 parts per million, and the sample standard deviation is 0.334 parts per million. Use technology to construct a 90% confidence interval estimate of the mean amount of mercury in the population. So we're going to use Statcrunch here. But before we use Statcrunch, do we use critical Z or critical T? They gave us the sample mean and sample standard deviation. So we're going to use critical T, because they gave us the sample standard deviation. Okay. We assume that this population is normally distributed, because the sample size is 1, 2, 3, 4, 5, 6, 7 stores. So we now assume that the population is normally distributed. So you click here on this icon, open in Statcrunch. You go to start. Let me put this here. Start, because we are going to use critical T, not critical Z. We're going to use critical T. Go to T stats. This is a one sample. If you want, you can use with data or with summary. It doesn't matter. However, let's use with summary. Why? Because they gave us the sample mean and the sample standard deviation already. So let's say one sample with summary. If you want, you can still use data. Okay, but let's go with summary. T stars, one sample with summary. The sample mean is 1.131. Sample standard deviation is 0.334. Sample size is 7. 1, 2, 3, 4, 5, 6, 7. And you're not performing hypothesis test. No, we are constructing a confidence interval. So you click here and you put this 0.9 or 0.90, 90% confidence interval. Okay, you click compute. So the lower limit to 3 decimal places will be 0.886, and the upper limit is 1.376. Okay, next one, my turn, my calculator. We can just refresh this to give us a new, and you can just reset this. Listed below are measured amounts of lead in micrograms per cubic meter in the air. The EPA has established an air quality standard for lead of 1.5 milligram per cubic meter. Sorry, microgram of 1.5 microgram per cubic meter. The measurements shown below are recorded at a building on different days. Use the given values to construct a 95% confidence interval estimate of the mean amount of lead in the air. Is there anything about this data set suggesting that the confidence interval might not be very good. Okay, so they gave us the data set. Let's find the we're gonna still use this. We're gonna use this here, but we need to find the mean and the standard deviation. They didn't give it to us. They did not give us the mean and standard deviation. So with my calculator, this is what you do. Still under estimating population mean, just scroll down and you just type in your data set here. So we'll type in this 5.40, 1.00, 0.48, 0.72, 0.74, 1.00, and you press calculate. Now let's get the mean. I'm gonna copy the mean, Control A, Control C, and I'm gonna come here, paste the sample mean here, paste the sample mean here. Okay, I had to shift it to the whole end because I didn't like the last three numbers. Then I'm gonna copy sample standard deviation. I'm gonna come here, paste it, sample standard deviation. Okay, confidence level is 95%. 95%. Test is one-tailed. Sample size 1, 2, 3, 4, 5, 6. Sample size is 6. You know what? It looks like I'm gonna put sample size here, so it will make it easy. So sample size 6. Press calculate. The lower bound or lower confidence limit is negative 0.430 to 3 decimal places, and the upper bound is 3.543. Okay. Is there anything about this data set suggesting that the confidence interval might not be very good? They didn't tell us here whether the population, that's the amounts of lead, are normally distributed. They did not, but we assume that. They didn't tell us, but we assume that for them to ask us to calculate to construct the confidence interval, even though they didn't say it in the question, we assume that the population of the amounts of lead in the air are normally distributed. But we look at the other options. So D, let's eliminate D. D is not it. A, yes, because the sample mean is greater than 1.5. That is not really a concern for using confidence interval. B, yes, the value of 5.40 appears to be an outlier. We eliminate A. Okay, let's leave B for now. C, yes, because the confidence interval does not contain 1.5. We eliminate C because the confidence interval actually contains 1.5. 1.5 is within the range of the confidence interval. Okay, 1.5 is in between negative 0.4 and 3.5. So we eliminate C. So I think the better option would be B. Okay. Question 9. We can use Statcrunch here. A data set includes 103 body temperatures of healthy adult humans, for which the mean is 98.1 degrees Fahrenheit and the sample standard deviation is 0.56 degree Fahrenheit. A. What is the best point estimate of the mean body temperature of all healthy humans? So of course the sample mean is the best point estimate of the population mean. So you put 98.1. B. Using the sample statistics, construct a 99% confidence interval estimate of the mean body temperature of all healthy humans. Do the confidence interval limits contain 98.6 degree Fahrenheit? What does this sample suggest about the use of 98.6 degree Fahrenheit as the mean body temperature? So we'll open up Statcrunch, go to question help, get Statcrunch. The sample size is 103, so that's fine. Now they gave us the sample standard deviation, so we will use t-stats. We'll use critical t-stats. You go to stats, t-stats, one sample with summary. The sample mean here is 98.1. The sample standard deviation is 0.56. The sample size is 103. You check the box confidence interval, and we are asked to construct 99% confidence interval. So this will be 0.99 as the confidence level. Then you click compute. The lower confidence limit to 3 decimal places would be 97.955. The upper confidence limit to 3 decimal places is 98.245. Okay. Do the confidence interval limits contain 98.6 degree Fahrenheit? As you can see here, it does not. It does not. 98.6 degree Fahrenheit is outside the confidence interval limit. So, no, it does not. Okay. What does this suggest about the use of 98.6 degree Fahrenheit as the mean body temperature? This suggests that the mean body temperature could be lower than 98.6 degree Fahrenheit. B. This suggests that the mean body temperature could very possibly be 98.6 degree Fahrenheit. No, we eliminate B right away. We eliminate B. C. This suggests that the mean body temperature could be higher than 98.6 degree Fahrenheit. We eliminate C because the maximum, the upper bound or the upper confidence limit is 98.245, and that is less than 98.6. So the answer would be A. Question 10. My turn. In a test of the effectiveness of garlic for lowering cholesterol, 48 subjects were treated with garlic in a processed tablet form. Cholesterol levels were measured before and after the treatment. The changes in their levels of LDL cholesterol in milligram per DL have a mean of 3.1 and a standard deviation of 18.3. A. What is the best point estimate of the population mean net change in LDL cholesterol after the garlic treatment. The best point estimate is the sample mean. The sample mean is the best point estimate of the population mean. So the sample mean is 3.1. B. Construct a 90% confidence interval estimate of the mean net change in LDL cholesterol after the garlic treatment. What does the confidence interval suggest about the effectiveness of garlic in reducing LDL cholesterol? So I'm going to use my calculator here. Confidence level is 90%, is already in percent. Test is 1/3. Sample standard deviation is 18.3. Sample mean is 3.1. Sample size is 48. Enter. So the lower confidence limit to 2 decimal places would be -1.33, and the upper confidence limit to 2 decimal places is 7.53. Okay. What does the confidence interval suggest about the effectiveness of the treatment? We see here, let's look at the options. The confidence interval limits contain 0, suggesting that the garlic treatment did not affect the LDL cholesterol levels. The confidence interval limits contain 0, suggesting that the garlic treatment did affect the LDL cholesterol levels. Then C and D, we eliminate them because C and D says the confidence interval limits do not contain 0. No, it contains 0. So as we move further in inferential statistics, when we actually get to hypothesis testing, you will realize if the confidence interval limits contain 0, what you do in such cases, what is your decision in such cases. If it contains 0, it suggests that the garlic treatment did not affect the LDL cholesterol levels. So we pick A. Okay. Question 11. Start crunch time. In a sample of 7 cars, each car was tested for nitrogen oxide emissions in grams per mile, and the following results were obtained. Assuming that this sample is representative of the cars in use, construct a 98% confidence interval estimate of the mean amount of nitrogen oxide emissions for all cars. If the EPA requires that nitrogen oxide emissions be less than 0.165 grams per mile, can we safely conclude that this requirement is being met? So we'll click on this icon, open in Statcrunch. Click here, opening Statcrunch. Here they didn't give us the sample mean and the sample standard deviation, so that's fine. I like to name my variables. I like to name it, so I'm just going to call this emissions. If you want, you don't name it, that's fine, but I like to name mine, so I call it emissions. So because we're given a sample, we were not given the population standard deviation. We will not use Z. We're going to use T. Okay, excuse me, we will use T. So go to Start, T starts, one sample with data with data, because they did not give us the sample mean and the sample standard deviation. Rather, they gave us the data. So you do one sample with data. Select columns to select the emissions, that is data. And we want to construct a 98% confidence interval estimate. So this gives us a confidence level of 0.98. Okay, and you press compute. So the lower confidence limit to 3 decimal places would be 0.064, and the upper confidence limit to 3 decimal places would be 0.176. Okay. Can we safely conclude that the requirement that nitrogen oxide emissions be less than 0.165 grams per mile is being met? So 0.165 is within this confidence interval. Okay, it is within that range of the confidence interval. So yes, because the confidence interval contains 0.165 grams per mile. Okay, so if we look at this question, we could easily say the answer is C. Yes, because the confidence interval contains 0.165 gram per mile. As you look at this question. However, let's look at all the options. Okay, A, no, because the confidence interval does not contain 0.165 gram per mile. So you eliminate A. B, no, it is possible that the requirement is being met, but it is also very possible that the mean is not less than 0.165 gram per mile. So the correct option now would be B. Okay. Question 12. My turn. And I'm just gonna reload this. 12 different video games showing substance use were observed, and the duration times of gameplay in seconds are listed below. The design of the study justifies the assumption that the sample can be treated as a simple random sample. Use the data to construct a 90% confidence interval estimate of the population mean, the mean duration of gameplay. So I'm gonna just come here, reset, and type in this data: 4055 3891 3864 4018 4328 4818 4657 4032 5004 4828 4344 4324. Calculate. So I'm gonna grab this mean, copy, I come here, sample mean, Control V, paste it. I'm gonna grab this standard deviation, copy, come here, sample standard deviation, paste it. Confidence level is 90% confidence level. Sample size is 12. Okay, enter. So the lower bound to 1 decimal place is 4142. 0.2, and then the upper bound is 4551.7. Okay. Question 13. Statcrunch turn. In a study designed to test the effectiveness of magnets for treating back pain, 35 patients were given a treatment with magnets and also a sham treatment without magnets. Pain was measured using a scale from 0, which means no pain, to 100, which means extreme pain. After giving the magnet treatments, the 35 patients had pain scores with a mean of 7.0 and a standard deviation of 2.4. After giving the sham treatments, the 35 patients had pain scores with a mean of 8.8 and a standard deviation of 2.6. A. Construct the 90% confidence interval estimate of the mean pain score for patients given the magnet treatment. So we go to question help, Statcrunch. We were not given the population standard deviation, so we are going to use the T. We'll use T. T-stat. So start, T-stats, one sample with summary. They gave us a summary. So for the first one, those that were given the magnet treatment, the sample mean is 7.0. Sample standard deviation is 2.4. Sample size is 35. Check the button confidence interval, and this will be 0.90. Compute. The lower bound is to 1 decimal place is 6.3, and the upper bound is 7.7. Then for the other one, you still go to start, T-stats, one sample with summary. Sample mean for those sham treatment without magnets. Sample mean is 8.8. Sample standard deviation is 2.6. Sample size is 35. And we construct a 90% confidence interval. So it's 0.90 as the confidence level. And you click compute. The lower bound to 1 decimal place is 8.1. The upper bound is 9.5. Okay. Compare the results. So we compare these results. This is with the treatment is 6.3 to 7.7, and without the treatment is 8.1 to 9.5. Looks like the treatment really reduced it. Okay, compare the results. Does the treatment with magnets appear to be effective? A. Since the confidence intervals overlap, it appears that the magnet treatments are more effective than the sham treatments. They don't overlap. This is between 6.3 to 7.7, and this is between 8.1 to 9.5. They did not overlap, no. So eliminate A. B. Since the confidence intervals do not overlap, it appears that the magnet treatments are more effective than the sham treatments. Okay. C. Since the confidence intervals do not overlap, it appears that the magnet treatments are no more effective than the sham treatments. D, since the confidence intervals overlap, so eliminate D. Now let's look at B and C. 0 is no pain, 100 is extreme pain. Okay, you look at the population mean here, 6.3 and 7.7. That is really reduced pain. And without the treatment is 8.1 to 9.5. That is bigger. So looks like those with the magnet treatment reduced the pain. So I will go with B. Okay, magnet treatments are more effective than the sham treatments. Okay. Question 14. My turn. A physician wants to develop criteria for determining whether a patient's pulse rate is atypical, and she wants to determine whether there are significant differences between males and females. Use the sample pulse rates below. With this, I would prefer to use Statcrunch since we are comparing. So we're going to use Statcrunch, okay? And let us do it 2 at a time. Let's do this 2 at the same time. So I click here, open in Statcrunch. Yeah, I prefer to use Statcrunch here. We are comparing two different data. It's better to use Statcrunch. So we're gonna go to they did not give us the population standard deviation, so we'll use t-stats. So we go to stat, t-stats. Once this is 2 samples now, 2 samples, not 1 sample. Okay, we have 2 samples with data, 2 samples with data. Okay, sample 1 is the male, sample 2 is the female. Okay, actually we don't want to use this. We don't want to do this confidence interval for the first population minus second population. So no, we won't use this. I'm gonna cancel this. See what we're gonna. This is not something we use here. We can do this for hypothesis testing, but not for this particular question. So I will still do it 1 sample each. Okay, I'm gonna still do it 1 sample each. When we go to hypothesis testing, then we can. I'm gonna show you how we do those for 2 samples. In this particular case, we are gonna do it differently for the male and for the female. When we now do hypothesis testing, then we can do the 2 samples. But for here, for this particular question, because it wants us to construct the confidence interval for the males and also the confidence interval estimate for the mean pulse rate for the females. So we go to start, t-stats, 1 sample with data. We get these 2. We select these 2 because we want to see it. Let's see it as a comparison. Let's see both together. Okay, so you click male first, and then you hold your control key. You hold you use your hand, press on the control key and select female. If you are using Mac, then you do you press your finger on the command key, and we're gonna do confidence interval for both of them, 95% confidence interval estimate for both of them, and we click compute. So in this case, we'll see the 2 right away. So please do not use 2 samples. No. Okay, we're gonna use 1 sample, but we'll select both of them. So for the males, to 1 decimal place, we have 63.3 and 81.5. The female, we have 75.9 and 100.1. Let's look at this here. We see there is overlapping. There is overlapping of confidence intervals for this particular question. 63.3 to 81.5, and here 75.9. So there's an overlap here. Compare the preceding results. Can we conclude that the population means for males and females are different? So A, yes, because the two confidence intervals do not overlap. Eliminate A right away. Okay. C, B, no, because the two confidence intervals overlap. We cannot conclude that the two population means are different. Yeah, B looks correct. B is the correct option. Okay, so we choose B. The confidence intervals overlap, and because of that, we cannot conclude that the two population means are different. Question 15. Now my turn. How about I use my turn now? An IQ test is designed so that the mean is 100 and the standard deviation is 18 for the population of normal adults. Find the sample size necessary to estimate the mean IQ score of statistics students such that it can be said with 95% confidence that the sample mean is within 3 IQ points of the true mean. Assume that the population's standard deviation is equal to 18 and determine the required sample size using technology. Then determine if this is a reasonable sample size for a real-world calculation. For the sample size, you cannot use Statcrunch anyway. You're going to use my calculator. I don't think Statcrunch calculates sample size. It does not. So I'm going to use my calculator. Now we want to find N. And they gave us the population standard deviation. So I'm going to make this bigger. This is still under estimating population mean. So look for to find N. And they gave us the population standard deviation. See that? So we'll use this. We'll use this right here. They gave us the confidence level and then the margin of error. Okay. So we're going to use that. We're going to use this calculator here. The population standard deviation is 18. The confidence level is 95%. Select percent. Margin of error within 3 IQ points. Within, this means the margin of error is 3. Okay, when you see within 3 IQ points of the true mean. So this is 3. Please do not select percent. Please select decimal, because this is like saying 3.00. In some cases it will be, if they say 3%, they use 3%, but this, in this case, 3 IQ points means like 3.00. So you put 3 and put decimal. Calculate. The sample size is 139. Would it be reasonable to sample this number of students? Yes, this number of IQ test scores is a fairly small number. Question 16. In order to estimate the mean amount of time computer users spend on the internet each month, how many computer users must be surveyed in order to be 95% confident that your sample mean is within 13 minutes of the population mean? Assume that the standard deviation of the population of monthly time spent on the internet is 209 minutes. So population standard deviation is 209. You want to be 95% confident. Okay. The margin of error within 13 minutes. So put 13 and it should be in decimal. Okay. So calculate the minimum sample size. The minimum sample size you should survey would be 993 computer users. What is a major obstacle to getting a good estimate of the population mean? A. It is difficult to precisely measure the amount of time spent on the internet in validating some data values. That's correct. B. There may not be 993 computer users to survey. Really? I mean, come on. A lot of people use computers. You can have that amount. You can have that sample, of course. So B, eliminate B. C, the data does not provide information on what the computer users did while on the internet. We really do not need to know what they did while on the internet. We just need to know the amount of time they spend on the internet each month. We are not really interested in what they do. I know they probably are on Facebook or Instagram. Hey, you know, I have some students say, you know, right from when I taught middle school. Hey, Mr. C, are you not on Facebook? I looked you up on Facebook. No, I'm not on Facebook. And I'm not on Instagram either. Wow. So C, we eliminate C. D, there are no obstacles to getting a good estimate of the population mean. That's not true. We eliminate D. So the answer should be A. Question 17. A student wants to estimate the mean score of all college students for a particular exam. First, use the range rule of thumb to make a rough estimate of the standard deviation of those scores. Possible scores range from 300 to 1200. Use technology and the estimated standard deviation to determine the sample size corresponding to a 95% confidence level and a margin of error of 100 points. What isn't quite right with this exercise? You're still gonna use my calculator because my calculator is the thing that will solve this question anyway. Statcrunch will not solve it. So I'm gonna come look for this here. This is the one I will use. The arrow here is the range, using the range rule of thumb. If you go to symbols and meaning, we wrote it here, range, using the range rule of thumb. Okay. So this is what we're gonna use here. We're gonna use this right here to solve that question. So the minimum here, excuse me, the minimum is 300, the maximum is 1200. This is 1200, okay. The confidence level is 95%. Margin of error of 100 points. So 100 in decimal, not in percent, please, in decimal. Press calculate, enter. So the range rule of thumb estimate for the standard deviation is 225. A confidence level of 95% requires a minimum sample size of 20. What isn't quite right with this exercise? A minimum sample size of 20 is not feasible to use to estimate the mean test scores. That's correct. B, a margin of error of 100 points seems too high to provide a good estimate of the mean score. That is also correct. C, the range rule of thumb introduces too much inaccuracy for this procedure. The range rule of thumb uses an approximate, gives an approximate value, an estimate of the standard deviation. Eliminate C. It's not too much inaccuracy, so that is incorrect. Eliminate C. D, these results don't apply to a test that has multiple choice questions. That's incorrect. Eliminate D. Now let us look at A and B. With A, of course, we talked about minimum sample size of 30 at least. But we don't know the population. Okay, the population might be normally distributed. So in that case, we will eliminate A. Now B, why I'm choosing B as the answer is because margin of error of 100 points is too high. It's too much. 100 points is too much. So it's too high to provide a good estimate of the mean score. So I'll go with B. Question 18. Using the simple random sample of weights of women from a data set, we obtain these sample statistics. Research from other sources suggests that the population of weights of women has a standard deviation given by, they gave us the standard deviation. That's the population standard deviation is 31.21 pounds. They gave us the sample size, 40 women. They gave us the sample mean, which is 143.94 pounds. Find the best point estimate of the mean weight of all women. That is the sample mean, which is 143.94 pounds. B, the 90% confidence interval estimate is what? So we're gonna use this here. They give us the population standard deviation. So we will use we use which one now? They give us the confidence level, which is 90%, population standard deviation, which is 31.21 pounds, sample size, which is 40, and the sample mean, which is 143.94 pounds. So we're gonna use this one. Confidence level is 90%, 90 select percent. Population standard deviation is 31.21. Sample size is 40. Sample mean is 143.94. Calculate. So the 90% confidence interval is, to two decimal places, is 135.82 and 152.06. Okay. Question 19. Randomly selected students participated in an experiment to test their ability to determine when 1 minute, which is 60 seconds, has passed. 40 students yielded a sample mean of 62.4 seconds. Assuming that the population standard deviation is 11.9 seconds, construct and interpret a 90% confidence interval estimate of the population mean of all students. Okay, let's use Statcrunch. Excuse me. Question help, Statcrunch. Let's get back to Statcrunch. So they gave us the population standard deviation. That case we'll use Z stats. Okay, in this we'll use Z stats, not T stats. So go to stats, Z stats, one sample with summary. The sample mean is 62.4. The sample standard deviation, the population standard deviation, okay, is 11.9. The sample size is 40 students. Select the option confidence interval. You want to construct 90%, so that is 0.90. Compute. So the lower limit, type integers or decimals rounded to one decimal place as needed. So the lower confidence limit is 59.3 and the upper confidence limit is 65.5. Okay. Based on the result, is it likely that the students' estimates have a mean that is reasonably close to 60 seconds? Of course, 60 seconds, the confidence interval includes 60 seconds. It includes it. So yes, because the confidence interval includes 60 seconds. Question 20, my turn. A study of the ages of motorcyclists killed in crashes involves the random selection of 169 drivers with a mean of 38.21 years. Assuming that the population standard deviation is 8.2 years, construct and interpret a 95% confidence interval estimate of the mean age of all motorcyclists killed in crashes. So we're gonna use this one. We're still gonna use this here. The confidence level is 95%. Population standard deviation is 8.2. Sample size is 169. Sample mean is 38.21. Calculate. The lower bound to two decimal places is 36.97 and the upper bound to two decimal places is 39.45. Okay. Notice that the confidence interval limits do not include ages below 20 years. What does this mean? A. The mean age of the population will never be less than 20 years old. Okay, that's correct. B. Motorcyclists under the age of 20 never die in crashes. That is incorrect. C. Well, for A, the mean age of the population will never be less than 20 years. Well, because of the never be, let's kind of leave it, but let's eliminate B. Okay, for A, because it says will never be less than 20 years, let's kind of keep it. B, let's eliminate B. C, the mean age of the sample will most likely not be less than 20 years old. When we interpret confidence intervals, it is about a population, not a sample. So eliminate C. Okay. Actually, the mean age of the sample is even 38.21 anyway. So eliminate C. D, the mean age of the population will most likely not be less than 20 years old. So you look at A and D. We will eliminate A because of the will never be less than 20 years. So we go with D, will most likely not be less than 20 years old. Okay. Question 21, Statcrunch. Salaries of 49 college graduates who took a statistics course in college have a mean of $61,000. Assuming a standard deviation, population standard deviation of $10,016, construct a 99% confidence interval for estimating the population mean. So we go to question help, Statcrunch. Stats, we're going to use these stats because they gave us the population standard deviation. So these stats, one sample with summary. The sample mean is 61,000. Please do not put a comma, okay? 61,000. Population standard deviation is 10,016. Sample size is 49. Confidence interval for the population mean, change this to 0.99 because of the 99% confidence interval. Then compute. Lower limit, round to the nearest integer as needed. Round nearest integer. So this will give us 57314. And the upper confidence limit will give us 64686. Okay. Okay. Let's now finish the rest. Question 22. The number of dash for a collection of sample data is the number of sample values that can vary after certain restrictions have been imposed on all data values. This is degrees of freedom. Degrees of freedom. 23. Which of the following is not a property of the student T distribution? Student T distribution has a mean of T equal to 0. That's right. Student T distribution is different for different sample sizes. That is correct. The standard deviation of the student T distribution is S equal to 1. That is incorrect. D, the student T distribution has the same general symmetric bell shape as the standard normal distribution, but it reflects the greater variability that is expected with small samples. That is right. That is correct. So the answer is C. The dash is the best point estimate of the population mean. Of course, the sample mean. Sample mean. Question 25. Which of the following calculations is not derived from the confidence interval? And you can, when you look at the formulas on my website or the notes, you can easily tell, you can easily find this. Population mean is upper confidence limit plus lower confidence limit. That is wrong. A is wrong. B is correct. C, do you notice that B and C is the same thing? If you multiply both sides by 2, B and C, you see it's the same thing. You multiply both sides by 2, okay? And then D is also correct, okay? So the answer that is incorrect is A, okay? The dash is the best point estimate of the population mean. I thought we just answered this before. It's the sample mean. They asked it again. Which of the following is not a requirement for constructing a confidence interval for estimating a population mean with the population standard deviation known? So A, either the population is normally distributed or the sample size is greater than 30 or both. That's correct. B, the confidence level is 95%. No, that's not a requirement. C, the sample measures a quantitative value. That's correct. D, the sample is a simple random sample. That is correct. So it's gonna be B, okay? 28. Which of the following would be a correct interpretation of a 99% confidence interval, such as 4.1 is less than the population mean is less than 5.6? So we are 99% confident that the interval from 4.1 to 5.6 actually does contain the true value of the population mean. C, we are 99% confident. 29. Which of the following is not an equivalent expression for the confidence interval given by 161.7 is less than the population mean is less than 189.5? The forms of this: A is correct. We now look at this here. Let's look at B and C. I'm just gonna, if you look at C, you look at B and C, okay, and D. We want this. We want it to be eventually this. So let's just go ahead and pull up the calculator real fast. We'll see here for B, you see that it's gonna be wrong, because 161.7, if you do minus 27.8, it will give you 133.9, okay, but we need 161.7. So that's not it. And you do 161.7 plus 27.8 gives you 189.5. Yeah, but the lower bound, the lower confidence limit is not represented. Now you look at C, okay, C and D is the same thing. If you do 175.6 minus 13.9, okay, that gives you 161.7. See that? Okay, and you also do 175.6 plus 13.9 gives you 189.5. So the correct answer below is B. Okay. Question 30. Which of the following is not required to determine minimum sample size to estimate a population mean? A, the value of the population standard deviation. No, we need that. B, the desired margin of error. We need that. C, the desired confidence level. We need that. D, the size of the population. We do not need it. So D is the correct option. Okay. We now save this and we call it a great night. Okay. If you have any questions, please feel free to ask. And you have a good night.